Following figure shows the arrangement of bar magnets in different configurations. Each magnet has a magnetic dipole vector m, which configuration has the highest net magnetic dipole moment we need to find here. Okay, if I'm going to observe the first option, that means here the magnetic fold will be moved from south to north, and here also the south to the north. Then the total net magnetic dipole, that is m net, which is equal to under root of 2 times m here. And in the second option, if I want to observe here, it will be moved from south to north, and again it will be moved from south to north. So total here the magnetic net magnetic dipole, that is m net, which is equal to 0. And here they are given in terms of angle. Then we know the relationship between the net magnetic dipole, that is m net, is equal to under root of m1 square plus m2 square plus 2m1 m2 cos of theta. Cos theta. Right. That means it is purely depend upon the theta value. If cos theta value it is increases, then definitely the net magnetic dipole value which is also increases. Then where theta value is less, in which case the theta value is less, here we need to find. Theta is equal to, it will be very less, the theta value will be very less, then cos theta value will be very high. Cos theta value will be automatically, it will be increases. Okay, if the theta value will be less, then the cos theta value will be increases. Then you will observe the theta value here. In this case, the theta value will becomes 90 degree. So here the theta value becomes 180 degree. And in this case, the theta value is equal to, they are given as 30 degree, and which is equal, in the fourth option, is equal to 60 degree. Then where the theta value is less, that is 30 degree. In this case, the cos of theta value will be increases. Then automatically the net magnetic dipole value is also increases. Then option C is the right answer here.